So now we will be doing the Wireshark activity. So using Wireshark to view network traffic. Let's see if I record now. Okay, so topology. Okay, we have the router. So it will our home router. Okay, so that is our default gateway. So objectives, part 1 is capture and analyze local ICMP data in Wireshark, and part 2 is capture and analyze remote ICMP data in Wireshark. So background and scenario, Wireshark is a software protocol analyzer or packet sniffer application used for network troubleshooting, analysis, software and protocol development, and education. So as data streams travel back and forth over the network, the sniffer captures each PDU or protocol data unit and can decode and analyze its content according to the appropriate RFC or other specifications. So Wireshark is a useful tool for anyone working with networks and can be used with most labs in the CCNA courses for data analysis and troubleshooting. So in this lab, you will use Wireshark to capture ICMP data pack, IP addresses, and Ethernet frame MAC addresses. Okay, so our main goal is to capture ICMP data packets containing IP address and Ethernet frame MAC addresses. So required resources is one PC, so Windows 7 or 10 with Ethernet access. So we have our PC, desktop with Windows 7, and additional PCs on local network will be used to reply to ping requests. So we will replace this additional PC with our phone. So our phone will reply to our ping request from the desktop. So part 1 is capture and analyze local ICMP data in Wireshark. Okay, so we will be dealing with local network. So in part 1 of this lab, we will ping another PC on the LAN and capture ICMP requests and replies in Wireshark. We will also look inside the frames captured for specific information. This analysis should help to clarify how packet headers are used to transport data to their destination. Okay. How packet headers. Okay. So step 1, retrieve your PC internet address. So for this lab, you will need to retrieve your PC IP address and its network. Okay, so our MAC address. So open command prompt, command window, and so can we, let's see, IP config. So I think it will be used as administrator. Okay. Config. Okay. So as you can see, let's see. Note the IP address of your PC interface, its description, and its MAC address. Okay. Let's see. Okay. So our IPv4. Copy. So 192.168.1.7. So that is our IP address. What else? And MAC address, physical. So our MAC address. So let's see. So this is our on desktop. And then let's see. So our MAC address. MAC address. This is our IP address. Now our MAC address is E0. So E0, D5, 5E, E9, 8B, and A4. Okay, this is our IP address and MAC address of our desktop. Okay, so as a team member or team members for your PC IP address and provide your PC IP address to them. Okay, do not provide them with your and provide your PC IP address. Do not provide them with your MAC address. Okay. But we're using our phone. Okay, let's see. So we will connect our phone to our network, so through our Wi-Fi. Let's see. Okay, so our phone, so the IP address of our phone is 192.168.1.2, and then the MAC address of our phone is, let's see, so our MAC address is 3C F7 A4 53 BA and FF. 3C F7 A4. Okay, so that is our phone IP address and MAC address. So we're using Samsung phone. Now step 2, start Wireshark and begin capturing data. So on your PC, click the Windows Start. Okay, then see if one, then double click Wireshark. Okay, so we're using Wireshark. Oops. Then after Wireshark starts, click the capture interface to be used because we are using wired Ethernet connection onto PC. Make sure that we're not using the Ethernet, just using our local area connection too. So you can manage the capture interface by clicking capture and options. Okay. Then a list of interface will display. Make sure the capture interface is checked under promiscuous. Okay, let's see. Okay, so our local area. It's still the internet. So link layer header is Ethernet. So we are our local area connection is checked on promiscuous. And then we can further manage the interfaces on the PC by clicking manage interfaces. Verify that the description matches what you noted in step 1B. Okay. Let's see. So close the management after there. Okay, let's see. Manage interfaces. Let's see. So what is EO? So right. Let's see, A4. EO, where have we seen D5, 5E, we're not seeing the 9. So we're not seeing our MAC address, so whatever. X, E5, local. I don't know. Okay. I think that is only description.
Kaya na nene, masarap ang ulam.
See. Wireshark client. Capture options, manage interfaces. I think it's on the description. Okay. So Realtek PCI EGBE family controller. Okay. So that's it. Okay. Close. Okay, next. Okay, where are we? So after you have checked the correct interface, click start. Okay, we'll be clicking start. You can also start the data capture by clicking Wireshark icon in the main interface. And this one. Okay. So information will start scrolling down the top section. In Wireshark, the data lines will appear in different colors based on protocol. Let's see. So start. Okay, we are seeing same type of protocol. So UDP protocol.
Buwa ba na sa TV ba?
Hindi ko lang po. Bumaba na po ate. Okay. So next. Okay. So this information can scroll by very quickly depending on what communication is taking place between your PC and the LAN. So we can apply a filter to make it easier to view and work with the data that is being captured by Wireshark. So for this lab, we are only interested in displaying ICMP ping PDUs type ICMP in the filter box. Let's see for okay. And press enter. Okay. So this filter causes all data in the top window to disappear, but you are still capturing the traffic on the interface. Bring up the command prompt window that you opened earlier and ping the IP address that you received from your team member. Let's see. So we're pinging ICMP. Right. Okay. Okay. So destination 107. I think because it is okay, now we will be pinging our ping the IP address that we received. Okay. So the MAC address is 192.168.1.2. So ping 192.168.1.2. Okay. So as you're seeing, so we got a reply from our phone. Okay, and that is captured by our Wireshark. Okay, notice that you start seeing data appear in the top window of our Wireshark. Okay. So note if the PCO does not reply to your pings. Okay. So but we reply. So it means because of PC firewall of the team members blocking this request. Okay. So stop capturing data by clicking the stop capture icon. Okay. So examine the captured data. In step 3, examine the data that was generated by the ping request of your team member PC. Okay, Wireshark data is displayed in 3 sections. So the top section displays the list of PDU frames captured with a summary of IP packet information listed. Okay, we can see our captured data, the source and destination IP address, the protocol, the length for packet, and the info. So it is a echo message or request and reply. Okay, so this is ID, sequence number, time to live. Okay. So the middle section lists PDU information for the frame selected in the top part of the screen and separates a captured PDU frame by its protocol layers. Okay, this is displays the information of the selected frame. So this is a ping reply. So from our Samsung. So this is our source. MAC address and destination is the gigabyte MAC address. So this is our MAC address. So E05, D5, 5E, E9, E5. Okay. And then the source is from our MAC address 3C, F7, A4, 53, BAF. Okay. Amazing. Then the bottom section displays the raw data of each layer. So the raw data is displayed in both hexadecimal and decimal. Raw data. Okay, this is our data on raw data of each layer. This is the raw data. Wow. ABCD. Okay. So next, click the first ICMP request video frames in the top section of the Wireshark. Notice that the source column has your PC IP address and destination column contains IP address of your teammate that you pinged. Let's see. So it's a ping request. So it's a request. Okay, so our source is our own IP address and the destination is the IP address of our cell phone. Next. So with this video frame still selected in top section, navigate to the middle section, click the plus sign to left of the view destination. Okay. You can see the Ethernet to frame. Okay. So the destination is our Samsung. Samsung. So it is our Samsung MAC address, and the source is our gigabyte MAC address. So that is our MAC address of our PC. It's an IPv4. Next, does the source MAC address match your PC interface? Yes. Okay, it also matches our destination MAC address. Okay, the MAC address of our cell phone. So how is the MAC address of the ping PC obtained your PC? How is the MAC address of your ping PC obtained? What? How is the MAC address of? So I think this because of ARP. It also, so it will be because of ARP. ARP request. Next, in the preceding example of capture, ICMP data is encapsulated inside the IPv4 packet PDU. Okay, so for transmission on the LAN. Okay. So part 2 is capture and analyze remote ICMP data in Wireshark. In part 2, you will ping remote host not on the LAN, and examine the generated data from those pings. You will then determine what is different about this data from the data examined in part 1. So step 1, capture data on the interface. So start the data capture again. So a window prompts you to save. What is this? The previous before something another. So it's not necessary to save the data. Okay. What we will be doing is, so start, continue with saving. We will do with the capture active, ping the following 3 website URLs. How can we ping that? Okay. So cisco.com, google.com. Can we ping this? Okay. We can ping this because we have the DNS. Oops. Okay, we are getting a reply. cisco.com. Okay, we're also getting a reply. Then ping from google.com. Okay, we can also get a reply. So when you ping the URLs listed, notice the domain names translate the URL to an IP address. Note the IP address received for each. Okay. So DNS translates our URL into an IP address. Okay, you can stop capturing data by clicking stop file. Okay, next. So examine the analyzing data from remote host. So review the captured data in Wireshark and examine the IP and MAC addresses of 3 locations that you ping is the destination IP address for each in the space provided. Okay, let's see. So this is from the first location. Okay, the IP. So we have 106, 10, 250, 250, and now the MAC address is this one, 94. Can we let's just copy it. So 94, 46, 96, A2, 54, and B3. Okay, this is the MAC address of yahoo.com. Oops. 94, 46, 96, 96, A2, 54, 54, and B3. Okay. For second location, we have 23. What is this? This one. No. Twenty-three, 46, 23, 46, 109, and 8. Then for the MAC address, we have EOD5, E5, 5E, E9. E9, that's 8B and A4. A4. Okay. Now for the third location, the google.com, 172 to 172 to 117, 161, 164. Then for the MAC address, EOD5, 5E. The same. EOD5, 5E. The same na. 89, 8B, A4. What? You have the same MAC address? Why? We have the same MAC address. No. Oops. No. She should be this one. $94, 46. Wait. Wait. Okay, wait lang. The source is, it's a reply. Okay. So So it must be the source. Bautech. They have the same MAC address. Okay, they have the same MAC address. Why is that? Okay. So what is significant about this information? They have different IP but the same MAC addresses. Why is that? They have different source but the same MAC addresses. How does the information differ from local ping information you receive in part 1? Okay. We have in IP address in a remote network. Okay. So meaning they have different network address than our address. And also, I think it is a public IP address. So it is a public IP address, and it differs from our private IP address. So why does Wireshark show actual MAC address of local host but not the actual MAC address for the remote host? Okay. So that is our. So it's an assignment for us. So why does? Okay. So we see same MAC addresses for remote host, right? I think that is the MAC address of. I think that is the MAC. Okay. So I think the reason why we have the same MAC addresses on the destination MAC address for when pinging remote networks, because that is the MAC address of our home router. Okay, we don't really have the destination MAC address of the our device in remote network, but the MAC address of our home router. Okay, that's why we have the same MAC addresses. So even if we have different destination IP address. Okay, so we already have. So I think this is for allowing ICMP traffic through fiber, but so that's it.